Hi everyone. In today's video, we will know about service mesh, what is service mesh, why we need, and how it works, and the architecture about service mesh. So let's go one by one. Agenda. What is service mesh? Why we need service mesh? Features of service mesh and architecture, and what are the advantages and disadvantages when to use a service mesh. In this video, we will know about this. So what is service mesh? Service mesh is an architectural pattern that manages the communication between microservice in a cloud native application, and also it helps to manage communication, security, observability and reliability within the microservice application. So it's a layer to handle the service to service communications, and also it's focusing on manage all the service to service communication with a distributed software system, and this makes communication optimization easier. And also service mesh usually uses a group of network proxies that are set up next to the main service, and the main service doesn't need to know about the proxies. So in these things, the mesh usually a group of network proxies, but main service doesn't know about the any proxies. Next, why we need service mesh? Service mesh is needed because as microservice architecture grow more complex, manage communication between services becomes increasingly difficult. And also without a service mesh, each microservice must individually handle network logic, security and fault tolerance, which complicates the application code. And it helps to reduce the complexity by centralizing communication management, enhancing security, improving observability, and optimizing the traffic rule. And also why we need this, because it's a reliability, or it improve the traffic control and retries, and the security means secure the communication through mutual TCS, and observability, here you can see observability. So it detail insight and monitoring of inter-service communications and policy management, and it's a centralized control of access and traffic policies. The next is features of service mesh. The main features are security, observability, traffic management, resiliency, and service discoveries. So this all are similar to benefits also. The benefits also are same: reliability, security, observability, traffic management. So the features, let's know one by one. The security. Security provide the encryptions, authorization, and authentication for securing service to service communication. So one service to another service we can communicate. It provides the authorization, authentication for each service. For example, mutual TLS. The next is observability. Collects matrices, logs, and traces. It's offering insight into how services are performing and interacting. Traffic management, load balancing, routing, and failover to ensure the traffic is routed optimally between the services. The resiliency. So it implements circuit breaking, retries, and timeouts to ensure the application is a fault tolerant and recover from failures. The next is service discovery. It automatically identifies available services in the network and allowing them to communicate without coding addresses. So it's helps in the service discovery. It helps to automatically identify what are the available services in those network, and it's directly allow them to communicate without any addressing. The next is service architecture, service mesh architecture. The service mesh architectures, it contains the control plane and data plane. So these are the main two key components of this architectures, and it contains sidecar proxy and observe and trace. So observe is observability and the trace. So let's know about one by one. The two main key components are control plane and data plane. So let's know what is control plane and how it works. The control plane plane acts as a brain of the service mesh architecture. So it's control all over the architecture. So it's mainly we are called as brain of the service mesh architecture. The orchestrating the configuration and management of the networks and the communication rules. So it's a configuring and management the network communication rules. We can communicate to control plane to data plane. It manages all the network rules. And the control plane provides a unified interface for administrator to define. So it's define the administrator to apply, monitor the policy across all the services. And also this enables dynamic updates and communicating management without direct code changes and redeployment. And also user or administrator can interact with the control plane via CLI, means using the command line interface or API server. The user or administrator can interact. The control plane manages the here we can see it connected to sidecar proxy. So it manages the sidecar proxy along the run and alongside the services and ensure the policies and configuration are consistently applied across all the instances. Then move to data plane. So data plane service are we called as east-west traffic. The data plane is where the actual traffic between the services occur. In this diagram we can see there are three instances. So instance A, instance B and instance C. So each instance has a sidecar proxy associated with it. Here we can see the green arrow mark we connected. So each instance a sidecar proxy is associated with it. The sidecar proxy handles all the network traffic for all its corresponding services instance. So it's corresponding to the service instance, and it ensure this data plane it ensure the request and response managed according to it. So it's ensure the response and request are according to the man. The control plane's rules providing enhancing security, observability and routing capabilities. It provide the security, observability and capabilities. The term east-west traffic refers the communication that happens between the different services within the data centers, as the east-west is opposite to north-south traffic, which refers to a traffic between the client and services. The next is here we can see the sidecar proxy. So sidecar proxy is associated with instance. So here we know about what is sidecar proxy and how it works. So each service instance has its own sidecar proxy that intercept the communication in both inbound and outbound. So it communicates between the inbound communication and outbound communication also. So these proxies handles tasks such as load balancing, service discovery and retires, which also enforcing the security policies such as mutual TLSs for encryption. The next is inter-server communication. So we told that it access inside and outside the communication. So inter-service communication means here we can see the blue line they connected through. So here it's connected and the instance and site proxy is connected. The inter-service communication means the green and blue arrow here we can see between the sidecar proxies indicate the communication between the service and the instance. So it's managed by their proxies. This sidecar manages the traffic between instance and ensure that or routing the decisions, security managers and observability tools are applied. The next is observe and trace. So it's observability, or also we can call and trace is tracing. So on the right, so here in this right side we can see boxes labeled as observe and trace. This represent the monitoring and tracing the functionality provided by service mesh. The sidecar proxies collect data on the traffic following through them. These sidecar proxies collecting data and the traffic. So it can be sent to monitoring system for observability. So it These sidecar proxies send the information to observability to monitoring the system, or tracing means it to trace the path of a request through multiple services. So using the trace box, we can tracing the request through the multiple service. This is all about the service mesh architecture. So I've already told the service mesh typically consists of two main components. One is data plane and another one is control plane. So I've explained all this in architecture. The next is advantages or pros of service mesh. So pros and cons are advantages and disadvantages also we call. So the advantages are it simplifies inter-service communication in container-based and microservice architectures, and it communication the errors occurs at the infrastructure layer and are easy to diagnose, and it support the security features like authentication, authorization and encryption. So it's accelerated the application development, testing and deployment, and sidecars located next to containers cluster can effectively manages the network surface. The main things are, so it's a security provider and easily identify the communication errors, and inter-service communication and development deployment testings are easy. The next is disadvantages. So using the service mesh increases the number of runtime instances. All services call must go through a sidecar proxy, so adding an extra step to communication the process. And the service mesh does not always support the integration with other systems or services, and it does not map transformation or provide the routing. The next is when to use a service mesh. So you can use service mesh when you need to manage a large number of microservices, or when you need to ensure the security communication between the services, we can use the service mesh. There when we use mainly means large scale applications, secure communication, complex network topologies, multi-cloud and hybrid cloud environments, application modernization and observability. One by one we will know. Site large scale applications. So when you have many microservices that need to communicate with each other, a service mesh can help you to manage the growing number of requests between the services. The next is secure communication. A service mesh can help you to manage the secure TLS connections between services and the complex network topologies. A service mesh can help you to manage communication across various network boundaries, such as across data centers or regions. The next is multi-cloud and hybrid cloud environment. A service mesh can help you to ensure consistent networking, security and observability across the different infrastructure environments. The next is application and modernization. A service mesh can help you to accelerate development cycles, reduce costs, and avoid the common implementation mistakes. The last one is observability. A secure mesh can help you to implement distributed tracing consistently across all the services, which can help you to troubleshoot and optimize the application. So these are all the times we can use the service mesh. This is all about the today's video. Thank you.